Okay, bridge students, today we have the side angle side triangle congruence theorem. You can see the objective. The key words in the objective are deductive reasoning. I'm going to really emphasize the deductive reasoning patterns connected to the side angle side triangle congruence theorem. The theorem is right here in brown, and you can read it. It says that if two sides in the included angle of one triangle are congruent to the two sides in the included angle of another triangle, then the triangles are congruent. And I want to emphasize the word included here. What that means, this idea of included, is to say you have a triangle. I'll draw one over here. This is just a random triangle. And this triangle has sides A and B. Then this angle right here would be included. Right there. Okay, so let's go to a problem. We're going to answer it right away in a narrow sense. We're going to talk about the logic behind it for a while. So here is the problem. We're going to find the value of the variable that results in congruent triangles. Looking at this picture below. And then it says, explain the deductive reasoning process that led you to your conclusion. I'm not going to ask you to do a proof here, but I want you to do the deductive reasoning process. So let's first, real quick, just kind of find an answer. You might guess, right, just looking at this, that what it wants you to do if you're an astute and experienced math students, which you guys are all getting to be, that all this is really going to have you do is set up 2p plus 14 equals 4p. Subtract 2p on both sides. And we get 2p equals 14 and p equals 7, which by itself is the right answer, but it's not very impressive. What's interesting is the reasoning process that takes us to this answer. I want to pull that out a little bit. And in doing that, I'm going to kind of show you the setup I have here. I'm not asking you to do a proof, like I said, but I am asking you to think about the logic. And I encourage you actually to stop the video right now and see if you can fill in the blanks. See if you can kind of think through why p has to be 7, essentially. Okay, and connect that to the side angle side triangle congruence theorem. So now I'm going to walk you through it. First of all, you may have noticed already, and if you haven't, this is a useful thing, that this line that I'm highlighting here, CA, is congruent to itself. This is no shocking conclusion, but it's an important part of the logic. So we're going to say that CA is congruent to CA by the reflexive property. So I'm going to write that down here. CA, this is line segment CA is congruent to line segment CA. All right, now I'm going to highlight something else. Different color. I'll go with, I don't know, orange. So here, this line segment AB or BA is marked as having the same measure as line segment CD or DC. So in other words, the measure of segment AB is 3 inches. The measure of segment CD is 3 inches. And since we have two things that are equal to another thing, in this case 3 inches, we can say that AB, segment AB, is congruent to segment CD by the, think about it, very important property, it's the transitive. Here we call it the transitive property of congruence. Okay, that should be a familiar property, and I'm just keeping a running list of our conclusions here. Our conclusion now is that AB, these are sort of like sub-conclusions. AB is congruent to CD. Okay. Let's look at this picture. I'm going to draw some dots here. So let's say I want you to make sure that everyone sees these two triangles. Hopefully you see them, but in case you don't, I can draw in some dots. We have this triangle here, ABC, and here I'm going to show purple dots for ABC. And we have another triangle, and it's going to be CDA, and I'm going to put in, I don't know, blue dots for CDA. We have these two triangles here. And I want you to notice right now how the marked angles, the angles that you've seen all along marked in red, right here and right there, they're included in between the two pairs of line segments that we've already marked as congruent. So in other words, this line segment and this line segment, and then this one is congruent to itself. Yeah? So we have, if we can show that those two included angles are congruent to each other, then we can use that SAS triangle congruence theorem. In other words, we know by the SAS triangle congruence theorem that if the included angles marked in red are congruent, in other words, we're going to call this angle BAC. I'll go back to my black color here. Angle BAC. And then the other one up here is going to be called angle perhaps ACD. And then the two triangles, let's start at this corner A. ABC. Triangle ABC. And triangle, we're going to label that one CDA. The order does matter here. You might want to think about that. That's not the emphasis of this lesson, but think about why I'm labeling it this way. Triangle CDA will have to be congruent. And so the question that we worked on right at the beginning here, using our instinct, is we have to find the value for P that makes those two angles congruent. It turns out that if P equals 7, then, a little bit more deductive reasoning here, angle BAC is congruent to angle ACD, and the triangles are congruent by what, guys? You said it. By side angle side. That's it. Fun work with deductive reasoning. Have fun with this lesson.